Hello viewers, welcome to NC Digital class. So in today's section we will be discuss about B tree and B plus tree. In last video we have already discussed about what is B tree, how can we form a B tree or how can we insert number of nodes in B tree, and in today's section we will be discuss about the deletion procedure for B tree as well as what is B plus tree and what is the insertion procedure of B plus tree and how the B plus tree is differ from B tree. Let's see the slide. These are the today's content: B tree deletion, B plus tree and B plus tree insertion. So in last class we have already discussed about insertion procedure, and in this class we will be discuss about the deletion procedure. In B tree deletion, if we want to perform deletion operation on B tree, that means if deletion of a value causes a node to be less than half of full, we know that if a B tree of order P, then the number of children, the maximum number of children it can be contained, that is P, and the number of key will be contained by a node, that is P minus 1. And whenever we are go for the deletion operation, if a deletion of a value causes a node to be less than half full, that means it is not satisfy the condition those must satisfy for the B tree, then it combining with the neighboring nodes, and this can be also propagate all the way to the root. In deletion operation, when the node is overflow, then we will move the key value, the mid key value to its corresponding parent node. But in deletion operation, if the node after deletion of the node causes to be less than half of its full, then in that case we may combine the node with its sibling nodes or its neighboring node to satisfy the condition for B tree, and it can also reduce the number of tree level. As well as in case of insertion, in the deletion operation, it can also reduce the number of tree level as compared to the general tree. So this is the tree that we have taken as the B tree or the initial tree, and this tree is formed after the insertion of number of nodes in B tree, and on this B tree we will be perform the deletion operation. Okay, this is a B tree of order 5 that we have already discussed about this. That's why each node must contain at least 3 children and at least 2 keys other than the root node, and the maximum number of children that can be a node can have, that is 5. Okay, and the maximum number of key for a particular node is 4, but at least they must contain 3 children and 2 keys, and the maximum value is maximum 5 children and 4 keys. Each leaf node must contain at least 2 keys. This is the condition for B tree, and we will be perform deletion operation on B tree. This is the initial tree, and suppose we want to delete the element H from the B tree. Okay, so see, H is present at this location. H is present at this location. Okay, as it is the leaf node, so we can simply delete this node. Okay, and whenever we delete this, the tree becomes like this. Okay, you can see H is deleted from this location. So delete H means, since H is in the leaf and the leaf has more than minimum number of keys, that means we know that leaf has 3 keys and the minimum number of keys in this case is 2. As it contains 3 keys, that means maximum from the minimum number of keys. So we can simply delete the key H from this node. So H is deleted, and after deletion the tree becomes like this. The node contain only the 2 keys, that is K and L. Okay, suppose we want to delete the node T. You can see here T is not a leaf node. Okay, it is an internal node. That means this node contains some leaf nodes. So like H, we can't delete this tree directly because it is not a leaf node, it is a internal node. So for deleting this, we will perform some operations. That is, since it is not a leaf node, so we must find its successor, the next item in ascending order. Okay, that means as it is not a leaf node, So we must find the successor node in ascending order. So this tree is formed in the ascending order, and the next successor ascending order node, ascending order key is W. So whenever we delete the T, then W will be moved to the location of T and T will remove. And when we move this W to its corresponding parent, you can see the leaf node still satisfying its minimum requirement of key, because the minimum requirement is 2 and it contains total 4 keys. So we can simply move this key to its internal, to its parent node, and we can simply delete the node. We can simply delete the key T from the internal node or from this node. See, this is the deletion procedure. Okay. Since T is not a leaf node, we can find its successor, that is the next item in ascending order, that is your W, which happens to be W, and move W up to replace the T. So we move W to replace the T, and that's why what we really have to do is to delete W from the leaf. Okay. Then here we delete W from the leaf and move to this location, and now still after that this node is also balanced. So in this way we delete the internal node as well as we delete the leaf node. Similarly, you can delete any node. Suppose in this case, suppose we want to delete the node L. Okay, let's consider, suppose we want to delete the node L, and when I delete this key value, okay, and then after this leaf node will not satisfy the minimum number of key, because the requirement is 2, but it contains still 1. So in this case we may combine its sibling nodes. We may combine these two nodes, that is the node containing key EF and the node containing the key K. Okay. In the similar procedure, we may delete this node. Suppose we want to delete X. So in the simple procedure, as the leaf node contains maximum number of keys, so we can simply delete the key X from this location. Okay. And still after, the leaf node will satisfy the minimum requirement of keys. So in simple way, we can delete the key X from the B tree. Okay. Then we will be discuss about B plus tree characteristics and what are the difference between B tree and B plus tree. Okay. B tree is actually what? In B tree, every value of the search field appear once at some label in the tree along with a data pointer. Okay. In B tree, you can see the data are stored at their node, but in B plus tree, there must be a data pointer and the data will contained by the leaf node. Okay, that is the difference between B tree and B plus tree. Okay, in B tree, data pointer are stored only at the leaf node of the tree, and the structure of the leaf node differ from the structure of the internal node. As the leaf node contain the data pointer, so the structure of the internal node is differ from the structure of the leaf node in case of B tree. Okay, let's say what are the different characteristics of B plus tree. Okay, as the structure of the internal node, so then comes to what are the different characteristics of B plus tree. The data records are only stored in the leaves, that I already told you. Internal node store just as keys. The internal node only store the keys, whereas the data records are stored by the leaf node. That's why the structure of both the nodes, that means the internal node and the leaf node, is differ in case of B plus tree. And the keys, those are used for directing the search to the proper leaf. The keys are basically used to direct the search of the proper node or the search of the proper leaf. The next characteristics, if a target key is less than a key in an internal node, that means the search key, the key which I want to search is less than the key in the internal node, that means those keys are present in the internal node, then the pointer just to its left is followed. Okay. If the search key or target key is less than the key in the internal node, then we will continue our search to the left of the node, or the pointer just to its left is to be followed. That means from this node we will search to left nodes. Okay. Then if the target node is greater or equals to, then obviously we will go for the right pointers. Okay. If a target key is greater or equals to the key in the internal node, then the pointer to its right is followed. If the target key is less, we will follow the left pointer. If the target key is greater, then we will follow the right pointer. Okay, this is the next characteristics. Then comes to last one. The B plus tree combine the feature of IASM, that is index sequential access method, and B tree. It follows the index sequential access method as well as B tree access method for the insertion, deletion and sorting a particular record. Okay. The next characteristics is we can implement on disks. It is likely that the leaves contain key pointer pairs where the pointer field points to the record of data associated with the key, and it also allows the data file to exist separately from the B plus tree, which functions as an index giving an ordering to the data in the data file. So these are the different characteristics of B plus tree file, and this is the time required for sorting a record or sorting a data in B plus tree. It is a very fast sorting process because it contains key as well as the data pointers to search a particular record, but the insertion and deletion are more expensive as compared to B plus tree. So let's see the insertion procedure for B plus tree, and in case of B plus tree, the maximum number of keys n to the power h, the minimum number of keys is 2 into n by 2 to the power h minus 1. Okay. Next we will see this is the structure of the B tree. That means you can see this is the B tree. Okay, this is the internal node, and you can see this is the key value, and there must be a data pointer at the leaf node. This is the structure of internal node, which is same as the B tree internal node structure, because each key have a pointer, that is left pointer and right pointer, which pointing towards left subtree and right subtree. But you can see in leaf node the structure is different because each key value with one data pointer. You can see this for each search value, the search key field value must be greater from its left sub pointer and must be less or equals to from its right sub pointer. Okay, this is the third characteristic. And each internal node has at most p pointer in case of B plus tree. Okay, each internal node except the root node has at least p by 2 pointer, and the root node has at least 2 tree pointer if it is the internal node. As like your B tree, B plus tree also have 2 pointer. If it is not a leaf node, then it must have a left pointer and it must have a right pointer. But as we know that the structure of the internal node is different from the structure of the leaf node, because in case of leaf node it contains the data pointer of each data, those are present in the B plus tree. Okay, but within each leaf node the key condition is same, that is K1 is less than K2, which is less than from K3. In this way we will be continue, and each data pointer that points to the record whose search field value is Ki or to a file block containing to the record. Each leaf node has at least p by 2 value, and all the leaf node are of the same label, that is B plus tree. Then next we will be see what is the insertion procedure for B plus tree. Okay. Suppose let consider we want to insert these data values in B plus tree. So first we want to insert 5. So let me define the order of the B plus tree. Here the order of the B plus tree is 3. That means here P is 3 and the order of the node is 3, and the maximum child it can contain, that is 3, and the maximum key value will be present as 2. Okay, that is P minus 1. So in this case 2. Suppose we want to insert 5, 8, 1, 7. Okay. And suppose first we want to insert 5. So as the node is empty, so I can simply insert 5. Since the node is empty, the value must be placed in the leaf node. Okay. And we will start insertion from the leaf node. Okay. Then next we want to insert 8. Since the node has room, so we insert the new value 8. As 8 is greater from 5, so it will be inserted at the right. Okay. Then next we will want to insert the value 1. Okay. You can see when we want to insert 1, the node is already full because the maximum key of each node is 2. So when we want to insert in this location, then this node will be split. And after splitting, the tree becomes like this. Since the node is full, it must be split into 2 nodes. Each node is half full. Okay. You can see when we insert 1, then it will be split into 2 nodes. Okay. 1 and 5 will be in one leaf node and 8 became in another leaf node and 5 becomes the moves to the its parent. Okay. Because it is a B plus 3. Then suppose next we want to insert 7. So 7 will be inserted. So first it will be compared with its parent nodes or root node. As it is greater from 5, so it will be go for the right pointer. And in this node, one node still one key is insert. So there is enough space to insert another key. So 7 can be inserted in this location. As 7 is less than from 8, so 7 will be inserted at the left side of the 8. Now the 7 is inserted in this node. Let's see. So when we go for inserting 7, so 7 is inserted in this way and we can indicate this by the sibling pointer because these 2 nodes are belonging from the node this. Okay. And this will contain 1 and 5 and 7 and 8. So in this way we will be insert node in B plus tree. Next we will see the deletion operation in B plus tree. Okay. You can see this is the root node and this is the tree which will form. Okay. And from this tree we have to delete 5, 12 and 9. Okay. So we can see the 5 is located in this location and whenever we want to delete the node, the key 5, then it will not from the half full of the node. So we can simply delete that node 5. So after deletion the tree becomes like this. You can see here the node 7 then 1 and from this location 5 is deleted. Okay. And when next we want to delete 12. Okay. As it is the node is full, so we simply delete the node 5. But in case of 12, when we are go for deleting node 12, you can see the node is underflow. Okay. That means the 12 is the one key which is present in this node and when we delete this, then the node will go for the underflow. As it is go for the underflow situation, so next come for the after deletion. As it is go for the underflow situation, so you can see, so the tree will form like this. That means 8 will become on this location and 9 will become on this location. Okay, this is the data pointer of which is located at the leaf node. Then we want to delete the node 9. So 9 is again located at this location and containing only one key in this node. Again 9 will go for the underflow situation. As it is go for the underflow situation, so we will merge it with its left node. Okay. So after deletion you can see the tree will form like this. So this is the root node. The 6 became go for the root and next we will merge the node as it is underflow. Okay. So this is all about your deletion operation in B plus tree. So this is the concept about B tree and B plus tree and how B tree is differ from B plus tree and what are the different procedure to insert a node in B plus tree. So keep watching. Thank you. Have a nice day.